Okay, so suppose you have a rectangular parcel of land and you want to know the coordinates of the corners, no? So obviously in traverse, you have to occupy corners, no? And then measure the distance and the bearing of this line, and then transfer here, and then you measure the bearing and distance of this line, no? And so on and so forth. Okay, so in other words, in a traverse, the concept of traverse is that you need to occupy the stations or corners so that you can determine the location of points. Okay, how about if you have this scenario wherein the corners or some of the corners are not accessible? It is because of some structures are being erected on it. Okay, so for example, these are the trees. No? So these corners, the three corners are obviously not accessible, or the instrument cannot be set up. It is because of the presence of the tree. So in the field, you have to establish, still you have to run a traverse, okay? But not necessarily that you have to occupy these corners, okay? So for example, you select a point or station, say T1, wherein a station that is more or less has a lot, or a number of corners or that are visible from T1. Okay, then maybe this is your T2 or station number 2. Okay, and then maybe this is your T3. Okay, or station 3. Okay, so by the way, in practice, now we usually call the traverse station as number T, capital number T with numerical number. So for example, T1, or that represent to traverse station 1. Okay, and then there are some that they have this T-1, meaning to say this is traverse station 1, or you can write that one as T sub 1. Okay. So back to here. So we have a three station traverse. Okay. So if you balance the traverse, you only have three lines. Okay. So how are you going to determine the coordinates of these corners? Okay. The answer is you have to take side shots. Okay. Side shots are actually observations taken at the traverse station to any point, and that point is not part of the closed traverse. Okay, so or for example, uh, you observe this point from T1, so that would be okay. So you have to observe the distance and okay, so the distance and the bearing or the azimuth, okay, or theta bearing, okay, and then uh, suppose this is also visible from T1, then you observe also. That would be you have your distance from this one to here, or I mean the distance from T1 to the tree or this corner, and also the bearing. Okay, and later you transfer to T2, and then you observe uh, this corner, no? And then maybe this corner, this corner, this corner, or all corners that are visible at T2. And then at T3, you also observe the corners that are visible at this station. Okay, so these lines or these observations are actually the side shots. Okay, this is useful because once we know, no, since the coordinates of T1, T2, T3 are known, and also the distance and bearing of the line or this side shot is known, then therefore we can compute the coordinates of these corners. Okay. Okay, so this is the enlarged picture of the previous slide. Okay. So we can say that there are a lot of corners. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's at least 15 corners now. And imagine if you occupy all the stations, so it would take time, no? So you have to occupy here, then transfer here, and then set up, no? Then here, set up, then here, set up. So it would take time. But doing the side shots, no? So it will lessen the field operations, or meaning the procedure, okay, in the field. Okay, so here I just want to show the top view of this parcel of land. So how to compute the coordinates of the side shots, no? Or the stations, okay? So these are the suggested steps. First, you have to compute the latitude and departure of the traverse, of course. The traverse, the T1, T2, T3, and T4, no? And then adjust the traverse, just the closed traverse. You have to adjust only the closed traverse. Next is using the adjusted latitude and departure, compute the coordinates of the traverse stations. Okay, so once the coordinates, once the traverse is adjusted, the next step is you have to compute the coordinates of T1, T2, T3, and T4. Okay, then after that, compute the latitude and departure of the side shots. Okay, meaning to say you have to compute this the latitude of these red lines, red dotted lines. Now this one, this one, this one, and this one. Okay. Then after that, you have to compute, or using the coordinates of traverse station, you can compute the coordinates of corners of the land. Okay, suppose you want to know the coordinates of corner 1, so you will use the coordinates of T3 and the latitude and departure of this line. Okay, if you want to know the coordinates of C3, then you have to use the coordinates of T2, okay, and the latitude and departure of this line connecting T2 and T3, okay, and so on and so forth. Okay, so finally you can locate, no, or you can plot that one, what is the form of your parcel of land, which in the figure is denoted as C1, C2, C3, C4, and C5. Okay, so take note, in the figure the T1, T2 to T4 are traverse corners or traverse stations, while land corners are denoted as C1, C2, C3, C4, and C5. Okay, so let us discuss it further by solving this example. Okay, so in here, you are given a traverse data. Okay, it is already adjusted, and in fact, the coordinates are already given. Okay, but in the real world, no, in real practice, you need to do the traverse calculation. Now, but in here, no, I will no longer discuss it because we already discussed that in the previous lesson. Okay, so another data is the side shots data. Okay, we have the station occupied, no, and then you have the station observed, the distance, and the azimuth. Okay, so we have at station A, the station being observed, or the corner being observed, is corner 1. At B, it is observed as the corner 2, and also the 3. And at D, corner 4 is being observed, no? And then these are the distances and the azimuth of the observations. Okay, so first is adjust and plot the traverse, which is already done. No, it is being adjusted, and in fact the coordinates are already computed. Okay, so suppose this is your A, okay, meaning to say that is 1000 and 1000, and then we can say that B is on the top of A by 27.86, and it's on the left, no, because it's 971. Okay, then our C would be above or lower than B, but it's above by A, no? It's above than A, no? And then it's on the east or on the west of point B, okay? So yon, this is point C, and then D is, it's 991, so it should be below, and then on the right, no? On the right, because it's 961 and it's 981, so it's a bit here, no? So that would be your D. Okay. So connecting the lines, no? So this is our closed traverse. Okay, the given closed traverse. So next is plot the side shots for proper view. Okay, so it is very useful if you make a sketch in solving this problem. Okay, so if you have AutoCAD, this is very easy to plot. Okay, so we will plot first at point A. So what are the observations conducted at point A? So we have only one, that is the corner one, and the distance is 828 and azimuth of 25 degrees and 1 minutes. Okay, so it's somewhere here, no? So it's our that is the azimuth is on the south, or the bearing is in the southwest. Okay, so it's around this much. That would be your corner one. Okay, so at station A, only one observation. Then at station B, there is corner 2, which is 8.14, 47 degrees, 29 minutes. So meaning still in this direction. Okay, and then the distance is 8.14. Okay, another observation at point B is corner 3. Okay, we have 23.41 meters, and then 289 degrees, 59 minutes. So it's somewhere on this direction. Okay, yun. And this is your corner 3. Okay, another observation was conducted at point D or station D. Okay, that is 41. Okay, and then the azimuth is 261 degrees. So it's something like that, no? 261 degrees, 52 minutes. Okay, so yun, and that is your point 4. Okay, so these are the locations of points being observed in the field. Now, although it is not part of the closed traverse itself, but it is part of the work, no, or the field work, no, or part of the traverse being conducted in the field. Okay, so next is compute coordinates or compute the coordinates of side shots using the respective latitude and departure. Okay, so compute the coordinates of side shots. Now using the respective latitude and departure. Okay, so we have here uh, the data, the side shots data. We have station A to corner 1, station B to corner 2, station B to corner 3, and station D to corner 4 with their respective distances and azimuth. Okay, so as what I have said, you have to compute the latitude and departure. So meaning to say, you have to use the distance, no, and the azimuth, that is here. Okay, and then you can compute now. So there's no need for me to, I think no need for me to present how to compute it, the latitude and departure. Okay, so if you look at this one, the symbol is, or the sign is negative, because azimuth is actually on the southwest, no? Southwest direction, no? 25 degrees. Next is we have negative 5.50 and negative 6. Still, it is negative. No, this is at point B22. So it's on the southwest direction. So that's why both latitude and departure are negative. Okay, for B3, you have 289. So that is on the southeast. Okay, so you have negative 8 and positive 22. Okay, so we have for D to 4. Okay, you have positive because in the northeast direction. No, that is 261. And the departure is positive 40.80. Okay, so next would be, okay, so by the way, if you connect the line, okay, so 2 to 3, 3 to 4, and 4 to 1. So actually, this is the lot. Now, this is the parcel of land that we are after of solving. Okay, then this is the parcel of land that you want to know the area, no, as well as the technical description, meaning the distances and the bearings of the lines of this or the sides of this polygon. Okay, so in order to do that, no, uh, we need to compute the coordinates. Okay, we need to compute the coordinates. Okay, so here these are the coordinates of the traverse stations, no, and then these are the latitude and the departure of the side shots. Therefore, we can compute the coordinates of 1, 2, 3, and 4. Okay, so for example, uh, for corner 1, so for corner 1, you have, okay, so for corner 1, okay, so for corner 1, okay, so since it is observed from A, so we will use the coordinates of A. Okay, so that would be northings. No, this is for northings. Okay, so corner 1 of that would be 1,000, and then plus the latitude, which is negative 7.50. Okay, and then that would be equal to 992.50. Okay, and for the corner 2, okay, you have, since corner 2 is observed from B, so you have to use 1027.86, then plus a negative 5.50. Okay, and then you have the answer of 1022.36. Okay, then for the eastings, we have also the, okay, for eastings, for corner 1, okay, you have 1000, then plus minus or plus negative 3.5. Okay, and then you have the answer of 996.50. Okay, for corner 2, we will use 971, no, and then my plus a negative 6, no, and then you have equal to 965.30. Okay, so same thing or same process that you have to do, and then you can compute the northings and eastings of the remaining corners. Okay, so in here, these are the answers. Corner 3 is 1019.86, which is computed from 3. So 3 is from B, so it's computed from 1027.86 minus 8, okay, minus a negative, oh no, plus a negative 8, so that would be plus, that's why you have 119 or 1019, And then for the departure, you have 971.30 plus positive 22.0. So that's why you have a 993.30. Okay. And then for corner 4, you have corner 4 is observed from point D. Okay. So you will use 991 plus a positive 5.83. So that's why you have 996.83. And then you have, for the eastings, you have 981 plus positive 40.80, and that's why you have 1021.80. Okay, so that's the process of computing the coordinates of these corners now, or the side shots. Okay, so this is the actually the this module, no. So this is actually the real practice of land surveying now, wherein you have to run a traverse, and then you have to take some side shots, and then finally you can plot the lot that you are observing. Here, no, I just want to show the coordinates of the computed coordinates of the lot, and this is the form of the lot being surveyed, no, plotted lot surveyed. And then after that one, since we have this one, and then we can compute the technical description of the lot. So take note, it's already line. Okay, line 1 2, not anymore A to B or A to 1, no, but it's line 1 to 2, meaning to say what is the distance and bearing of this line, then this line, this line, and this line, no. So you have that one, no. So this is essential, no, when you apply for titling, no. So title of the lot, no, or the property, this is the data that you need to get, no. And your survey must be approved by the DENR, and then they have to check also your process, how the survey is being conducted. And then finally, the technical description, such as this one, will be approved by the DENR. Okay, so let's wrap up Module 4. Okay, so first we discuss on the traverse. We define traverse and the traversing, and then we were able to adjust a closed traverse as well as the open traverse. We were able to compute the coordinates of traverse stations, also the coordinates of side shots or the survey lot. And then finally, we were able to compute the technical description of the lot. Okay, so that's the end of module number 4, and thank you.